Okay, let's have a look at the next question. I'm asked to find the value of x, an angle. Looking at what's involved in the question, I have two sides and two angles. Once again, the only formula I have that involves two sides and two angles is the sine rule. Now usually, the sine rule is written with a over sine A equals b over sine B. You'll notice I never bother with equals c over sine C because it's not really needed for the problems we're doing. But we could choose to write this formula upside down. I could write it as sine A over A equals sine B over B. They're both fine, and I want to pick the one which is going to be easiest to work with in any given question. It actually doesn't matter, they'll both give you the right answer, but in this case I'm going to pick this one, because I'm interested in an angle, and if the angle is on top of the fraction, that's going to give me less steps to do in my algebra. So now I'm going to follow the opposites rule, so I know what's substituting where. Sine x over 24 is going to equal sine 71.8 over 39. If I multiply by 24 on both sides, I can get sine x equals 24 times sine 71.8 divided by 39. That's going to give me 0.5846. And then I take an inverse sine of that to get me my final answer. X equals 35.8 degrees. On to the next question. Now, bearings questions are quite common in these topics. And when we're looking at bearings questions, we want to always remember our parallel line geometry rules. Often, one of the most useful rules is the interior angles rule, which says that if I've got two parallel lines, then these two angles over here, A and B, will add up to make 180 degrees. This is almost always useful in a question involving bearings. And don't forget about your alternate angles and your corresponding angles as well. So, A, B and C are three towns. The bearing of B from A is 110 degrees. The bearing of C from B is 280 degrees. AC is 38, AB is 50, and I want to find the bearing of A from B. Pay attention to this word from. From tells you where the angle is. I want to get to A from B, so I'm interested in going all the way around here until I'm pointing at that line there. Now I already know most of that journey is 280, so I need to work out this angle in here. The temptation is to straight away start thinking about sine rule or cosine rule or something like that. But remember your geometry rules, these are simpler. North lines make parallels. And here I have, between the 110 and this angle in here, that interior angles rule I was talking about before. If I know these two angles must add up to make 180 degrees, then this angle must be 70. The angle all the way around a circle has to make 360 degrees, and so far altogether I've got 280 plus 70 is 350 degrees. So the missing angle in the triangle must be 10 degrees. So the bearing of A from B, remember bearings are angles measured clockwise from a north line. I have to go all the way around to here clockwise to get that angle. 280 plus 10 is 270 degrees. Now it's asking me to calculate the angle BAC. Well, BAC is this angle over here. So forgetting about everything outside of the triangle, I'm looking at a question involving two angles and two sides. So it's a sine rule question. But we're going to encounter a bit of a difficulty when we're trying to work out the sine rule, because I can't use the opposites. This is quite a common problem, and the way we resolve it is like this. We look for where we can work with opposites. These two are fine, and this side is opposite this angle over here. So I'm going to call that angle x. and work that one out. Now that's not the one that's being asked for, but because I know the angles in a triangle add up to 180 degrees, I can use it to get the one I'm being asked for. So, sine x over 50 is equal to sine 10 over 38. And I can multiply by 50 to get sine x equals something. So, sine x is going to equal 0.228. And some other stuff. I'm going to hit the inverse sine button to get myself an answer for x, 13.2 degrees. Remember, the angle I'm actually being asked for is BAC. So 180 minus 13.2 minus 10 is going to give me my final answer. And that is 156.8 degrees. So, this strategy of working out the other angle that's not being asked for and then subtracting from 180 to get the one they're asking you for is quite common and shows up quite a lot. Do remember it. Now here we're getting an interesting question. A road is built from A to join the straight road BC. And I want the shortest possible length of this new road. Now, the shortest possible length of a line is one that meets at right angles. If I'm going from A to this road over here, and I want to take the shortest possible path, that's going to be the one that hits at 90 degrees. This is important because 90-degree angles mean we can work with right-angled triangles. So I'm going to get rid of some of my scribbles over here, and I'm going to draw very carefully on the diagram what we're working with. I'm just going to include my 10 degrees again there. So from A to the road BC, I want to hit at right angles like this. Now that's created a right angled triangle on this side, and it's created a right angled triangle over here on this side as well. And I can choose which one I'm going to work with in order to calculate the length of this line, which I'm going to call x. In fact, I've already used x, so I'll call this h. Now I'm going to choose to work with the triangle on this side, on the right-hand side. It doesn't matter which one we choose, because actually we did work out this angle as well. I'm going to use trigonometry with that triangle. And the reason why I've chosen on the right-hand side is because I know all these measurements exactly. I didn't have to do any rounding at any stage. So I want to work out this side. I've got a side and an angle, and I want another side. This is a trigonometry question, but because it's a right-angled triangle, I get to use right-angled triangle trigonometry. Looking at this thing, I've got the opposite and the hypotenuse. I don't care about the adjacent, so I'm going to use sine theta is opposite over hypotenuse. Sine 10 equals h over 50, so h equals 50 sine 10. And we can work that out. 50 sine 10 gets me 8.68 kilometers, and that's my shortest distance. So remember, shortest distances from a point to a line, they're always going to meet at right angles. So now we have a question where cones are getting involved. Now cones can get involved in sectors questions because if you open out a cone, what you get is a sector of a circle. So for this question, we need to know that the area of that curved section of a cone, this curved area here, that's equal to pi rl, where r is the radius and L is the length of that diagonal line over there. That's going to be important for this question. We also need to imagine what measurements are going to go where when this thing is opened up. So for instance, this curved length over here on our sector would actually be the circumference of the base of the cone. And the radius of this circle is going to be the same as the length of that diagonal side of the cone, 10. So now let's see what we've got. The cone is cut along the line OP and opened out into a sector, and I want to calculate this angle x. Well, I have enough information to work out the area of this curved part of the cone. That curved area is equal to pi times 3 times 10, or 30 pi. I could work that out as a decimal, but just for fun I'm going to leave it as 30 pi, and that means I'll have less in the way of rounding errors later on. That area must equal the area of this sector. So 30 pi, the sector area, is equal to that angle over 360 times the area of a circle, pi times 10 squared. And I can use this to work out x. Pi is appearing as a factor on both sides, so I can cancel it out. So x equals 30 times 360 divided by 10 squared divided by 100. And I can work that out straight away. Just take note for a second, if I'm dividing by 100, that divides by 10 here and here, so all that goes away. I'm just doing 3 times 36, which is 108. So x is 108 degrees. 108 degrees. You don't have to do it this way, you don't have to cancel out pi's and do all this stuff with fractions. You can make full use of your calculator and work with the decimals, but I'm always pointing these things out when they're available to you. And more questions in the next video.